Hello, fellow programmers. Welcome back to our exciting journey into the world of C++, brought to you by Alibo Market. Today, we're diving into a fundamental concept that will revolutionize the way you write code functions. Functions are the building blocks of well-structured programs. They allow you to break down complex tasks into smaller, more manageable chunks. This modular approach not only makes your code easier to read and understand, but also promotes reusability. In this installment, we'll explore the ins and outs of functions in C++. We'll learn how to declare them, define their inner workings, and call upon them whenever we need to perform specific actions. So buckle up and get ready to unlock the true potential of C++ with functions. Let's begin our exploration. Imagine you're building a house. It's a complex project that requires careful planning and execution. Would you try to build everything at once, all mixed up? Of course not. That would be chaotic and inefficient. Instead, you'd break down the construction into smaller, more manageable tasks. You'd start by organizing your materials and planning each step carefully. You'd build the foundation first, ensuring it's strong and level. Then, you'd move on to constructing the walls, followed by the roof, and so on. Each step builds upon the previous one, creating a solid structure. Functions in programming are like those individual construction tasks. They allow you to break down complex problems into smaller, more manageable pieces. By grouping lines of code together to perform specific actions, functions help you organize your code and make it more readable. Instead of writing the same code over and over again, you can put it in a function and use it whenever you need it. This not only saves time, but also reduces the chances of errors. For example, let's say you're writing a program to calculate the area of different shapes. You could create a function for calculating the area of a circle, another function for a rectangle, and so on. By doing this, you can easily reuse these functions whenever you need to perform these calculations, without having to rewrite the code each time. This modular approach makes your code more organized and easier to understand. It also makes it easier to debug, as you can isolate and test individual functions. When your code is organized into functions, you can quickly identify where something might be going wrong and fix it without having to sift through hundreds of lines of code. Functions are essential for writing efficient and maintainable C++ programs. They help you manage complexity by breaking down tasks into smaller, more manageable pieces. By using functions, you can write cleaner code, reduce redundancy, and make your programming life a whole lot easier. They empower you to tackle complex problems with confidence and efficiency. Moreover, functions facilitate collaboration. When working in a team, well-defined functions make it easier for different team members to understand and work on different parts of the code base. In summary, functions are a powerful tool in programming. They help you write more efficient, maintainable, and reusable code, making your projects more successful and your work more enjoyable. Before you can use a function in C++, you need to tell the compiler about it. This is a crucial step in the coding process, as it sets the stage for how your program will understand and execute the function. This is called declaring a function. Function declarations are like the blueprints of a building, providing a detailed plan before any construction begins. It's like showing the blueprint of a house before you start building it. Just as an architect needs a clear plan to construct a house, a programmer needs a function declaration to build a program. A function declaration tells the compiler three main things: the function's name, the return type, and the parameters. These elements are essential for the compiler to understand how to handle the function. The function's name. This is how you'll refer to the function in your code. It's like giving a name to a room in a house blueprint, so everyone knows what it is. The return type. This is the type of data the function will give back to the main program. Think of it as the type of material a room is made of in a house, defining its purpose and use. The parameters, these are like input values that the function can use. They are similar to the dimensions and specifications of a room in a blueprint, detailing what is needed to build it. Here's an example of a function declaration: int calculate area, int length, int width. This declaration tells the compiler about a function named calculate area. It takes two integer parameters, length and width, which represent the dimensions of a rectangle. and it returns an integer value, which will be the calculated area. This is similar to how a blueprint specifies the dimensions of a room and the materials needed, ensuring everything is clear before construction begins. And it returns an integer value, which will be the calculated area. This return value is crucial as it provides the result of the function's operation, just like a completed room in a house. Declaring a function is like showing the blueprint. Defining it is like actually building the house. The function definition is where you write the code that will be executed when the function is called. The function definition looks very similar to the declaration, but it includes the code block within curly braces. This code block contains the instructions that the function will perform. Here's an example of a function definition for our function. Int calculate area, int length, int width. Int area equals sign length asterisk width return area. This definition first calculates the area by multiplying the and parameters. Then it uses the keyword to send the calculated back to the main program. Section 5. Calling functions. Putting them to work. Once you've declared and defined a function, you can use it in your code. This is called calling a function. It's like asking the construction workers to build a specific part of the house based on the blueprint. To call a function, you simply write its name followed by parentheses. If the function takes any parameters, you put them inside the parentheses, separated by commas. Here's how you would call our function int result equals calculate area 10, 5. This line of code calls the function with the arguments 10 and 5. The function calculates the area, which is 50 in this case, and returns it. The value 50 is then stored in the variable. Section 6. Return types giving back to the program. We've briefly touched upon return types, but let's dive a bit deeper. Understanding return types is fundamental to mastering any programming language. The return type of a function specifies what kind of value it will send back to the main program. This is essential because it dictates how the function's output can be used. A function can have any data type as its return type, such as integers, doubles, strings, or even custom data types. The flexibility of return types allows for a wide range of functionalities. For instance, an integer return type can be used for counting operations, while a string return type might be used for returning text data. Custom data types, on the other hand, can be tailored to fit specific needs, making your code more modular and reusable. If a function doesn't need to return any value, its return type is void. This is often used for functions that perform actions but don't need to report back any information. Here are some examples to illustrate these concepts. This function takes two integers as input and returns their sum as an integer. This is useful for arithmetic operations. This function takes two doubles as input and returns their average as a double. Such functions are often used in statistical calculations. This function doesn't take any input and doesn't return any value. It might simply print a message to the console or perform an action like updating a user interface. It might simply print a message to the console, update a database, or trigger an event in the application. Understanding return types is crucial because it determines how you can use the result of a function in your program. It affects how you design your functions and how they interact with other parts of your code. By mastering return types, you can write more efficient, readable, and maintainable code. This knowledge will empower you to create more complex and powerful programs. So take the time to practice and experiment with different return types. The more you understand them, the more versatile and effective your programming will become. Section 7. Alibo Market, your gateway to knowledge. A big thank you to Alibo Market for sponsoring this series and making these tutorials possible. Alibo Market is committed to making programming accessible to everyone. Don't forget to check out their website and subscribe to their channel for more amazing content. Your support helps us create more informative tutorials like this one. Section 8. Recap. Functions in a nutshell. In this installment, we embarked on an exciting journey into the world of functions in C++. We learned that functions are like building blocks that make our programs more organized, reusable, and easier to manage. We explored how to declare functions, providing a blueprint to the compiler. We then delved into defining functions, where the actual code resides and the magic happens. And finally, we saw how to call functions, putting them to work and reaping the benefits of modular programming. Remember, functions are your friends in the programming world. Embrace them, use them wisely, and watch your code transform into a masterpiece of efficiency and elegance. Section 9. What's next? Passing arguments to functions. But wait, there's more. In our next exciting episode, we'll delve deeper into the world of functions and explore the concept of passing arguments. We'll discover how to make our functions even more versatile by allowing them to accept different inputs and produce dynamic results. So stay tuned for more C++ adventures, brought to you by Alibo Market. Until then, happy coding.